Hello and welcome to this video. To start off with inverse trig, I'm gonna just talk about the idea behind it. So it works like this. So I know that sine of 53.13 degrees, right? I know that sine of 53.13 degrees is going to be equal to the opposite over the hypotenuse, right? So this is going to be equal to 4 over 5. And 4 over 5 is about 0.8, right? So if I keep that in mind, and then I look here, and I'll call this theta. So what's sine of theta? Well, since I have these sides of this triangle, I know that it's going to be 8, right, for the opposite here. Here's the hypotenuse, 8 over 10. But that's the same. That's 4 over 5, or 0.8. So the idea is, if I know that sine of theta is 0.8, and I know that sine of 53.13 is 0.8, then it stands to reason that theta has to be 53.13. In other words, if I have a trigonometric ratio, if I have enough sides, I should be able to get the angles of my right triangle, right? So inverse trig is used to solve for angles. Of course, it doesn't work like this. It's a little bit easier. And that's the idea we'll get to here. So just for the first introduction, if sine of 53.13 degrees is equal to 0.8, then inverse sine, which we write like that, of 0.8, you put the original ratio into the inverse, and you get out the angle, right? And we can test that real fast. All right, so I'm gonna hit function here, and I'll find the inverse button right there, the second one down on the left, and I put in 0.8, and you can see I get 53.13. So that's the idea. You start with the sides or the ratio, and you figure out the angles. So we'll just write these down pretty quickly. All right. The easiest way, I think, to remember them is I just start with, so sine of theta is equal to opposite over hypotenuse, and sine, the inverse sine, right? So that symbol there, that to the -1, is going to mean inverse. The inverse sine of opposite over hypotenuse will give you back the angle, right? And then because some students have preferred it in the past, you might also like to write if sine of if sine of theta, or if sine of theta is equal to x, then the inverse sine of x is equal to theta. Same sort of thing. All it is you put the ratio into the inverse, and it gives you the angle back out. All right, so cosine of theta is equal to adjacent. We know that, adjacent over hypotenuse. So cosine, the inverse, right? The inverse of cosine, if you put the ratio adjacent over hypotenuse in there, it'll give you back theta. And then finally, tangent. If I have tangent of theta, I'm looking at opposite over adjacent, right? And therefore, if I want to use the inverse, I'll put opposite over adjacent in there, and I will get theta back out. Right? And I can include the examples for this one right in here. So let's just take a look. Again, we're going to use this to find angles rather than just a moment. I'm going to use this to find angles. Thank you. All right, we're going to use this. We're going to use this one to find angles rather than sides. All right, so for an example, right, we might give us a right triangle, and I'll tell you, hey, this is 6 and this is 20. And we have A, B, and C, and you might be asked to find, right, determine the measure of angle A, right? So the first thing I'm gonna say to myself here is, all right, A is my focus angle, which means the hypotenuse doesn't change. Opposite is 20, CB here, and adjacent, right, is 6, adjacent. So I'm going to say, what did they give me, right? What is given? Well, in this case, they gave me opposite and adjacent. So I look at my SOHCAHTOA, and I ask myself, which one uses opposite and adjacent? And that's tan. So I know that tan, let's write that a little bit nicer. I know that tangent of theta is equal to opposite over adjacent. So in this case, I'll write that up here. So tan theta is equal to opposite over adjacent. In this case, it's equal to 20 over 6, or 10 over 3. So using the definitions we wrote down earlier, right, you can see it up there in green, I know that the inverse tangent of 10 over 3 will give me back theta if I put it in a calculator. So I go to the calculator. If I can zoom out here. All right, I'll just move over a little bit. So I go to functions, tan -1, and I put 10 over 3 in there, 10 divided by 3, and it gives me back my angle, which is 73.3 degrees, rounding to the nearest tenth. Right, so 73.3 degrees is equal to theta. Well, I named it theta, so it's actually the measure of angle A is equal to 73.3 degrees. Right? And let's look at one more example of that before this video ends. Right? So another example, and we have, I will just draw a right triangle here. And we'll give this top part, we'll call this maybe 15, and we'll call this, I don't know, 18. All right, so, and let's say we'll call this X, Y, and Z. So for this one, let's say they want us to find the measure of angle X is equal to something. All right, so once again, I'll put a theta here by my x, and I'll say, hey, what did they give me in regards to theta? Well, this time I have a hypotenuse across from the right angle. That doesn't change. 15 is adjacent. So they gave me adjacent and hypotenuse. So that means I'm going to use cosine, because cosine of theta is equal to adjacent over hypotenuse. So I'll just put in, if I know that cosine of x, I'll use the proper symbol here, cosine of x degrees is equal to adjacent over hypotenuse. So 15 over 18. And I can divide both those by 3. So maybe 5 over 6. Then that means I can use the inverse of cosine. Inverse cosine. I put the ratio in there, and it should give me back. It should give me back my theta, or my x, the measure of angle x, right? To be even more specific, I guess we could put the measure of angle x, right? So bring out the calculator, and cosine, inverse cosine, 5 divided by 6, 5 divided by 6, and I'm looking at about 33.5556 degrees after rounding. Normally we're asked to round to the nearest tenth, so 33.6 degrees. So 33.6 degrees is equal to the measure of angle x. And that is what using inverse trigonometry looks like. Thank you so much, and good luck. Please let me know if you have any questions at all. Email, Teams, whatever you need. Bye.